Sorry about the having to click on two videos, but I was 7 minutes in and I forgot to put my phone into airplane mode, and my dad called and I didn't want to redo this thing. So anyways, as we were saying here, that when we talk about the heavier elements, we're not talking about hydrogen. Hydrogen was just one of those, since it only needs one proton and then one electron cruising around it, then it's called a light element. And it would make sense that there's the most of this in the universe. There's actually like 73.9% that. Okay, because think about it, if you only need one proton, that's really easy to make. Okay, so next up is helium. Remember, even though this, other than making our voice sound cool, if we suck helium out of a balloon, we don't really need this, but that only takes 2 protons. And if you don't remember from when we talked about electricity, remember protons and neutrons are in the nucleus. We still don't really care about neutrons. Then the electrons are cruising around the outside of it. So helium only needs 2 protons in there. So 24% of our universe is helium. And these two processes happen with nuclear fusion, which we'll write about here in a second. What you are going to do now, though, is pause me. I know we just got going on the second video clip here, but you're going to pause me and watch. I think it's like a 4-minute NOVA video where they're going to go through the whole dang periodic table and show you how stars create every single element. And like our sun can't, because it's not big enough, but some of those real massive stars, they'll go out with a bang. They'll go out with a supernova, okay, that explosion, and that ends up causing iron, which is kind of like the last thing that can usually fuse together, to transform, to keep it simple, into even heavier elements. All right, so pause me. I'm not going to stop this video, or you'd have to click on 3 of them. All right, so pause me, watch the NOVA video, come back to me. All right, so hopefully you found that relatively interesting. I know some of the scientists were a little dry here and there, but it's still kind of cool how just the nuclear fusion process within a star, where we take hydrogen, make sure we can see this good. So hydrogen plus hydrogen within the core of a star to make helium. So that's that 2 plus thing that we talked about a day or 2 ago. Okay, 2 hydrogens make helium. And then, okay, it's going to get hotter and hotter, and it starts to collapse down. Once we run out of fuel, the star doesn't say, okay, I'm just going to die. It won't do that, but it'll start to collapse. And when it collapses, it gets even crazy hotter because of the pressure, and then we'll start to fuse the heliums. And I feel like they said it takes like 3 of them, something like that. So I guess we can have 3. Doesn't matter that much. But eventually then, we're able to get carbon, which if you look down here, carbon has an atomic number of 6. Now within the whole entire universe, there's only 0.46% carbon. So not about, if you want to say a half of 1% of the universe is carbon. It's harder to make it. So oxygen, and this is kind of a freak thing in my mind, but oxygen has actually 8 protons. So it's harder for stars to make that. Yet 1.04% of the universe is oxygen. Okay, so we fuse heavier things together. Maybe you take 4 heliums and now we can make 1 oxygen atom. Okay, again, this, and this. These guys, that's like the basic of anything that's alive, has those things in it. And those are all going to be generated from, or at least originally generated from the stars. Just to keep going here, nitrogen is an atomic number of 7, remember. Any of you that are trying to build some muscle mass, this is what you're focused on, is nitrogen, 0.096. So not even 1% of the universe. Sulfur, we just need very, very small amounts, 0.044. And phosphorus, sorry, I should have put those in ascending order, but even less of this. All right, but either way, what we look at is we fuse these light ones, and as more and more and more pressure builds up, we are able to generate the heavy elements. All right, that was kind of the gist there, just to see where all this stuff originally came from. And don't get that confused like with the carbon cycle on Earth. you know, throwback to middle school and water cycle. Sure, once it's here, yeah, we recycle everything on this planet. But like how, when you're talking about the planet formation, it hasn't just always been cruising out there. So that explosion ended up generating it, and the stars ultimately created the elements that we now have here. Okay. All right, our time has come to an end in terms of notes.